next example you'll need to watch to get the password to get in the 2.4 homework assignment in coursecompass.com. Uh, it's very similar to the problem on page 90, the ones with samples, finding the range, mean, variance, and standard deviation of sample data set. And there's a difference between using the sample and the population. The range, mean are pretty much the same, but when you get to the population and the sample, they're going to be a little bit different. So if you go back in your textbook, I think it's a really good idea if you're using a textbook as much as you possibly can, and you'll see that the formulas for the population and the sample are different. So here is the population standard deviation, and you can see they use sigma for the standard deviation, which is the square root of the variance. So here's the variance, and I use this formula. The denominator is just n, which is the population size. For the sample, it's n minus 1. So you need to make sure you're paying attention to that. So let's take a look at this video.
This is section 2.4, page 97, number 3. Find the range, mean, variance, and standard deviation of the sample data set. If it was a population data set like numbers 1 and 2, then you would have a different calculation, a different denominator for the variance and standard deviation. So you need to be careful with those. And so our data here, we have the data. And let's find the range. So the range of the data is just the highest value minus the lowest value. So our highest value here is the 18, and the lowest value is the 6. So we just take 18, take away 6. And that'll give us a range of 12. The next thing we want to find is the mean. So to find the mean, we just add up our numbers here, and that would be sigma x. And then we would divide that by n, and that's the mean. So sample x bar, the mean, is just the sum of the x's, which is numbers they give you, divided by n. And we can do that in our calculator too. And so what I think is a really good idea is just to use your lists as much as you can here when you've got a lot of numbers. And this isn't so many numbers for this one. So we're going to go to our list by hitting stat and enter. We need to clear out what we have in here already. So we're going to go to the top and hit clear arrow down. And we're going to use a couple other lists too for this. Let's clear these out. So let's put our numbers in list 1. So you just type the number, press enter. So we have 17, enter, 8, enter, 13, enter, 18, enter, 15, 9, 10, 11, and 6. And so they're all the numbers that they gave us. And there's 9 numbers, so it says L110. That means you're in the 10th space. Go back to the main screen, and we can find the sum of those. And so we hit second mode to go back to the main screen. So to find the sum, you hit second, stat, go over to math. We want to find the sum, which is number 5, of L1. So second one is L1, it's the blue L1. And so that gives us a sum of 107. So that means our sigma x is 107. And then how many numbers are there? 1, 2, 3, 4, 5, 6, 7, 8, 9. So we're going to divide that 107 by 9 to find out our mean. And we get a mean of 11 point. That 8 is going to look to that 8 and make that 8 go up to 9. We're just going to go one decimal here. So it's 11.8 repeating, but we're going to say it's about, that symbol is for about. Actually, it's just like a shake and equal sign, 11.9. And so we're going to use that for our mean, and that's what we're going to use for our x bar when we get to the next thing that we need to find, which is the variance. So the variance, the formula for the variance is going to be, it's s squared, which is the variance. That's something we need to find now. So for the sample variance, it is the sum of, or sigma, x minus x bar, x being these numbers, minus x bar, and so we would do x minus x bar, we'd have a column here, and then you would square that, and then divided by n minus 1. And this is for a sample. For a sample, it's n minus 1. If it was a population, it would just be the capital N. So pay attention to what they're asking for. It would be capital N for the population. And so you wouldn't do the minus 1. So because of the error, that's why they did minus 1. But I'm going to do this in my list. So you could do it by hand. You would do 17, take away 11.9 squared, and get a number, and do it for all these, and then add them up. And we're going to do that. We're going to add those up. That's what this segment means. But let's use our list. So if we go back to our stat enter, in list 2, we can just go very tippy top of list 2, and we'll just do our open parentheses, just like this here, x, which is in list 1, all of our numbers in list 1, so second one, minus x bar, which is our mean. We get 11.9, rounded correctly, close parentheses, and then square. And your x squared button is kitty corner from your 7 there. Press enter, and all those numbers are going to fill in for you. And we want to find the sum of those. And if you do this by hand in your calculator, you would have gotten 26.01. Each one of those, you would have gotten that number. And so we're going to go ahead and find the list sum of list 2. So second one, to go back to the main screen, I've got the sum L1 here. So I'm just going to hit second enter a couple of times because I don't feel like going through all those buttons. And I'm going to back arrow, and it's in list 2 now, so second 2. So the sum of list 2 is 136.89. And that is going to be the numerator for our variance here. So we get 136.89. And then n is 9. We're going to do 9 minus 1. And so the variance, or s squared, is going to be 136.89 divided by 8. And we're going to get that to be about, let's say about instead of equal to, about 17.1. Make sure you pay attention to what they want you rounded off at. And so that's the variance, 17.1. Now they want the standard deviation. So the standard deviation is simply the square root of the variance. The formula for the standard deviation, and that's going to be s, is the square root of the variance, which is the square root of sigma x minus x bar. Remember, this is sample squared, so it's going to be n minus 1 instead of n. And so we've already done all that inside, so we're just finding the square root of our 17.1. So that's going to be about the standard deviation, the s, the sample standard deviation, is going to be about 4.1. So make sure you pay attention to whether you're doing a population or a sample. And use that calculator as much as you can. It's really, really helpful.